Flying is considered the most climate-damaging form of transportation. Every year, millions of people take to the air. During the past 10 years alone, passenger numbers have increased by 50%, and experts forecast continued growth. Just one of the reasons for airlines to look towards bigger planes and higher capacities, such as the A380, currently the largest airliner in the world. The aircraft can carry more than 800 passengers. With a maximum takeoff weight of 560 tons, the aircraft rises majestically into the sky. Particularly during takeoff and landing, enormous forces act on the wings. Under extreme conditions, the tips of the wings may distort upwards by more than 7 meters. It used to be that aircraft on this scale could only handle these forces by using special steels or aluminium alloys, but always at the expense of weight. Over the past few years, however, much lighter materials with the same or even improved toughness have been developed. They're made of textiles, and they're known as technical textiles. Like their relatives used in clothing or around the home, they're produced on textile machines. The equipment delivers more than a meter of cloth a second and is the result of decades of research and development, producing high-tech meshes that are up to 50% lighter than aluminium. Details are key in saving weight. Unlike steel or aluminium, textile fiber materials can save weight simply by determining the direction of the acting external forces. The stability of the material can be affected by placing the stability-providing fibers appropriate to the direction that the external forces are acting on the structural part. For example, for parts stressed by torsion, that would be at 45 degrees to the length of the component. The basic material is carbon fiber. Each of these strips consists of about 600,000 filaments, 6 million threads per square meter. Finally, they're sewn with a special yarn. 500 needles pierce the material with incredible precision at up to 1,000 times a minute. The result is a cloth of extreme resilience. Carbon fiber reinforced plastics made of this textile have the advantage of offering highly complex shapes, more complex than possible using steel or aluminium. And the carbon fiber is tougher too. Both factors contribute substantially to weight saving. The carbon fiber fleece is formed into its future shape and smoothed with precision. Every pleat could be seen on the finished component. Saturated with resin, the fleece will be baked at 60 to 70 degrees in a special oven. Depending on the individual fleece, the end product can assume any shape: a massive strut or a filigree hollow profile. For the A380, parts of the body are made of these webs. 20% of the gigantic plane is made out of carbon fiber composites. The goal is to achieve a lower weight, to save fuel and to reduce emissions. Over half of the newest Airbus, the A350, will be made of this lightweight material. The new aircraft will weigh about 10 tons less than an A330, allowing Airbus engineers to reduce emissions to 30% below the UN standard, and achieving the lowest passenger kilometer consumption in its class, to below 5 litres. With carbon fiber made by textile machines, we're on course for the 3-litre plane.